Dear students, welcome back to a new mathematics session. In today's session, we shall discuss a new chapter, that is chapter 8, Applications of Integrals. We will discuss the problems from exercise 8.1. Let's move on to the topic. Let's begin with question number 1 from exercise 8.1. Find the area of the region bounded by the curve y square equal to x and the lines x is equal to 1, x is equal to 4 and the x-axis in the first quadrant. So here the curve is y square is equal to x. The lines are given x is equal to 1 and x is equal to 4. And the portion lies in the first quadrant. The region lies in the first quadrant. First of all, we need to make a rough diagram. Then only we can identify the area from which area to which area we need to calculate, and from where to where the limits, that also we have to identify through the diagram. Here the curve is y square equal to x. Y square equal to x means clearly it is a parabola. And a parabola, we know 4 types of parabola we have learned, and y square equal to x, easy to identify. You see here y square is with y, means positive or negative value is not a problem here. Plus or minus y, x is plus x. For plus or minus y, x is always positive. That means when we consider the parabola opens towards the right side of x-axis. See, just a rough sketch only this one. X-axis, y-axis we will draw. This is the x-axis, and then y-axis we have drawn. And after that, for positive or negative y, positive or negative y means throughout the y-axis we can take the points, but x should be always positive. Means this side only we can consider x value. That means the parabola opens this way towards the right side. That means just simply draw it, a rough sketch like this. It will be coming the parabola, and parabola is finished. Then we need to identify the lines. X is equal to 1 means x-axis particular point 1 and x-axis 4. 4 will be coming after 1, maybe here. Okay, roughly we can draw. It's not necessary to take accurate points here. So x is equal to 1 maybe comes this way. So just we need to write that is x is equal to 1. Then another line will be x is equal to 4. It will be coming after 1. So this we can write it as x is equal to 4. Okay, so roughly we have identified. Then area, which portion area we need to calculate. Clearly in the question it is mentioned region bounded by the curve y square equal to x, means below this curve, particular curve, parabola, between the lines x is equal to 1 and x is equal to 4. That means between these two lines and the x-axis, that means region bounded by the x-axis in the first quadrant, means above x-axis. So this is the area we need to calculate. So roughly we have drawn the diagram. Now we have to draw the original diagram. Original diagram drawing means make sure that you use your instrument box like ruler, compass. If it is necessary, compass you use, or else simply you can draw with your hand, and a pencil, scale, all those things you have to use. It should be a neat and legible diagram. Y square equal to x is the curve, x is equal to 1 and x is equal to 4 are the lines, and region we have identified here, shaded with the blue color, and you can shade with your pencil. Now how do we find out the area? For finding out the area, what we do is, we have explained before this one, from this particular portion we will take a small strip. So this is the basic portion that is explaining only for this question. Small strip we will consider. Small strip means it is in rectangular shape, considering as a rectangular shape. So a small length from the x-axis we will take, that we will take as a dx, and corresponding breadth, that is the y-axis value, that will be y. Okay, so since it is a rectangular portion, we know the area, that is length into breadth. Length dx and breadth is y, or breadth is dx and length is y. Anyway you can take, it's not a problem. So area can be calculated by using the area formula, that is length into breadth. So y dx will be coming. So y dx is the area formula. Then for finding out this entire area, what we have to do is just integrate this y dx from x is equal to 1 to x is equal to 4 by applying the limits. That is the way we are finding out the area under the curve. And integration, we know that integration means it is the area under the curve. Okay, then required area is equal to integral 1 to 4 y dx. And remember, when the limits are given to you, x is equal to 1 and x is equal to 4, means the limits are in terms of x, means we will write it as y dx. And when the limits are in y terms. That means y is equal to 1 and y is equal to 4 if it comes, means here we will write as this one will write as x dx. Okay, so we will be calculating x dy. That is the way we will write. When it is given to you in terms of x, so limit will be writing 1 to 4 and will be coming as y dx. Okay, when these terms x is equal to 1 and x is equal to 4, instead of x, if it is given to you y values, means what we will write is here will be coming as x and here will be coming as dy. Okay, x dy will be coming. So that is the way we are going to do. Just a simple techniques only, all these things. Then y we need. Here you see y square equal to x. From there y we have to calculate y is equal to root x. The mental calculation is enough. Y is equal to root x. So integral 1 to 4 root x dx. Then integral 1 to 4 root x we can write as x power 1 by 2 dx. X power n integration formula is x power n plus 1 by n plus 1. That is 1 by 2 plus 1 is 3 by 2. X power 3 by 2 by 3 by 2. Apply the limit 1 to 4. Denominator is 2. That will go to the numerator. So it will be coming as 2 by 3 into. Here apply the limit 4 power 3 by 2 minus 1 power 3 by 2. And here there is a little work. Is there 4 power 3 by 2. So 4 power 3 by 2, how do we calculate? 4 power 3 by 2 we can split as 4 power 1 by 2. That we can write it as 4 power 1 by 2. Then the whole power 3. Okay, this is the way we have to write the whole power 3. 4 power 1 by 2, we know that is square root of 4. Square root of 4 is 2. 2 power 3. 2 power 3 is what? 8. So this is the way we need to calculate that power. So 4 power 3 by 2 we have calculated, that is 8. 1 power any quantity? 1 itself. So 2 by 3 into 8 minus 1, that is 2 by 3 into 7. 2 by 3 into 7 is 2 into 7, 14 by 3 square units. So this is the required area. Next we shall discuss the second question. Find the area of the region bounded by y square equal to 9x, x is equal to 2, x is equal to 4 and the x-axis in the first quadrant. Like before, we will go with identifying the area, identifying the region. So y square equal to 9x, clearly it is a parabola. And just like the previous question, for positive or negative value of y, x is positive. So clearly it will be opening towards the right side of x-axis. So this is the way it will be coming. Little wider on will be coming as we compare with the previous one, because here 9x, y square equal to 9x. So for positive or negative y, x is positive. Then there are two lines it is mentioned, x is equal to 2 and x is equal to 4. X is equal to 2, of course we can take this way, x is equal to 2. So this we can write it as x is equal to 2. And the same way x is equal to 4 we can consider another line, that is this way, just after 2, that is x is equal to 4 we have taken. Then again the same thing only, and the x-axis in the first quadrant means this portion. X-axis in the first quadrant is this portion. This is a rough sketch, so keep it here. Then y square equal to 9x we can take. From there y we can calculate. Y is equal to root of 9x, that is equal to 3 root x. Why we are calculating y? As I said before, the limits are given to you in terms of x. When x limit is given to you, means our formula will be y dx. So that's why y we need. Okay, so y we have calculated 3 root x. Draw the diagram properly. Y square equal to 9x, that is the parabola, and x is equal to 2 and x is equal to 4, 2 lines, and the region we have identified, that is this portion. So you need to simply shade it with your pencil. Okay, this portion is shaded so that you will be able to easily identify the portion while solving. Okay, so this is the portion area we need to calculate. So required shaded area is equal to integral 2 to 4 from here to here, 2 to 4 y dx. Okay, y dx means a small strip will be taking. The previous question it is explained here. There will be y and there is small portion in the x-axis, that is dx will be considering. Area means length into breadth, that's why y dx is coming. Or else by using this portion also we will be able to write this formula. Means here x limits are given to you, that's why will be coming here as y dx. Okay, then substitute the value of y, integral 2 to 4 3 root x dx. That is 3 is a constant, keep outside. Root x value is x power 1 by 2. When we find out the integration here, 3 into x power 1 by 2. Integration is x power 1 by 2 plus 1. That is x power 3 by 2 by 3 by 2. Apply the limit here. Then denominator will go to the numerator. That means already 1 3 is there, into 2 by 3. This 3 by 2 will be coming 2 by 3. Apply the limit here, 4 power 3 by 2 minus 2 power 3 by 2. And here also little work is there. This 3 numerator denominator we can cancel. 4 power 3 by 2, just like the previous question, we can split 4 power 3 by 2, we can split as 4 power 1 by 2, 4 power 1 by 2 the whole power 3 we can write. 4 power 1 by 2 we know it is square root of 4. Square root of 4 is 2. 2 power 3, that is equal to 8. That is the first part answer. Again, one more portion is there, that is 2 power 3 by 2 is there. 2 power 3 by 2, the same way we can split. 2 power 3 by 2 we can split as 2 power 1 by 2, 2 power 1 by 2 the whole power 3, the whole power 3. 2 power 1 by 2 means we know that is a root 2. Root 2 value we know, but we don't substitute. So root 2 power 3 will be coming, means we have to multiply 3 times. So root 2 into root 2 into root 2. And root 2 into root 2 means 2. 2 will be coming. Again, one more root 2 is there. So 2 root 2. We can simplify and keep. Okay, this is the way. So when we substitute 2 into, here all outside 2 is there. 4 power 3 by 2 is 8 minus, here we calculated 2 root 2. And when we multiply inside, 2 into 8 is 16 minus 2 into 2 is 4 root 2 square units. So this is the required area. Next we shall discuss the third question. Find the area of the region bounded by x square equal to 4y. So now the equation is changed. X square equal to 4y, y is equal to 2 and y is equal to 4, and the y axis in the first quadrant. So here we can just draw a rough diagram. For that, just identify which type of parabola it is. X square means for positive or negative x is not a problem, but y should be always positive. Y should be always positive means positive side of y axis is upside. That means upward open parabola will be coming here. And here y is equal to 2 and y is equal to 4 means the limit is in terms of y. So what we can do, the formula will be x dy will be coming, means from here we have to calculate x. Okay, so rough idea should be there how we have to proceed. Then just we will draw the rough diagram. There will be x-axis and y-axis will be there, and as I said before, for positive or negative x value, that means this way it will be coming. Positive or negative x value means here it is a negative x, but y value is positive. Here it is positive x, y is also positive. Then y is equal to 2 and y is equal to 4, just like the previous one only. Y axis it will cut. Y is equal to 2 means here it will be coming, so we can write it as y is equal to 2, and another one is y is equal to 4. It will be just above that, y is equal to 4. And the required portion or required region is in the first quadrant. First quadrant means here this is the portion we need to identify. We have identified and we will be going for calculating the area. Rough sketch is ready. Then as I said before, our formula will be x dy. So that's why we will be calculating from here x square equal to 4y. From here x is equal to root of 4y. Root of 4 we know that is 2. Root 2y is there. Then diagram we will draw neatly by using instrument box. And as I explained before, all the things are there. Y is equal to 2 line, y is equal to 4 line. This will be considered as the limit. And here integration formula is required area is equal to 2 to 4 x dy. 2 to 4 x dy means how this one will be coming. X dy formula derivation, if you want, will be tell you. But there we will be taking a small strip here like the previous one, but we will take the opposite way. A small strip will be taking a small length from the y axis, that will be dy. And the corresponding value or the length will be considered as x, because this is the length. This is the length means this is the x axis value. The small length is this one, that is the y axis value. That's a dy is taken. As before, length area in rectangular portion area formula is length into breadth. That x is not clear, so a little bit bigger way we will write. So this is x. Okay, then x into dy, that's why this formula came. Okay, two way also it is explained. Directly shortcut we can use, or else from the diagram also we can find out. Then apply it. Integral 2 to 4 x, we have calculated 2 root y. Then root y we can write as y power 1 by 2, and 2 we can take outside. So 2 into 2 to 4, integral 2 to 4 y power 1 by 2 dy. So as before, 2 into y power 1 by 2, integration is y power 1 by 2 plus 1 by 1 by 2 plus 1. Y power 1 by 2 plus 1 is 3 by 2, y power 3 by 2 by 3 by 2. Apply the limit. Same like the previous one only. Then denominator will go to the numerator. So there already one 2 is there. This 2 will go up. That means 2 into 2, 4. 4 by 3 into, apply the limit, 4 power 3 by 2 minus 2 power 3 by 2. So 4 power 3 by 2 we can write it as 4 root 4. So here how it will be coming, 4 power 3 by 2 we can split just like previous one, just to split and calculate. Okay, so each and everything it is explaining means it will be a problem, so some work we need to do as your own. Okay, 4 power 3 by 2 we can write it as 4 power 1 by 2, 4 power 1 by 2, then the whole power 3. Okay, directly also we can write as 8, that is 4 power 1 by 2 is root of 4, root of 4 is 2, 2 cube is 8. But directly we can write, but here 4 root 4 is mentioned. Then next is 2 power 3 by 2. 2 power 3 by 2, how do we come in? 2 power 3 by 2 we can just write it as 2 power 1 by 2, 2 power 1 by 2, the whole power 3 by 2. Okay, so previous question also it was explained. Okay, 3 by 2, sorry, whole power 3, this is 1 by 2. Then what we can do, 2 power 1 by 2 is root 2, root 2 the whole cube, root 2 whole cube is root 2 3 times, so root 2 into root 2 into root 2, root 2 into root 2 is 2, then one more root 2 is there, so that will be coming as 2 root 2. Okay, this is the way we will be calculating 2 root 2. So it is written finally 4 by 3 into 4 into 2, directly we can write 8 minus 2 root 2. Okay, then what we can do is here just multiply inside 4 into 4 16, 16 into 2, 16 into 2 is 32, minus 4 into 2 8 root 2 divided by 3, taking 3 as common LCM here, or just we are multiplying inside and taking 3 as common LCM, square units. This is some way we have done the calculation, but you can just proceed with your own way, just like the previous question. These steps you can just include and complete the work. Answer is 32 minus 8 root 2 divided by 3 square units. Next we shall discuss question number 4. Find the area of the region bounded by the ellipse x square by 16 plus y square by 9 is equal to 1. So this is the equation of the ellipse, and the ellipse we have studied two types, and one is the major axis along the x-axis and another one is the major axis is y-axis. So how to identify the major axis, that is the first thing. Just think the denominator, think of the denominator. Here denominator is 16 and 9, and clearly 16 is bigger, and bigger denominator is under x square. So the major axis is x-axis. Identify the denominator and which one is bigger. Just to see the numerator, that will be the particular major axis. So here the major axis is x-axis. So the figure comes this way. Major axis x-axis means that x-axis length will be more. Okay. So it will be, ellipse will be covering more length in through x-axis. Okay. And y-axis, when we compare, this is y-axis length, that will be comparatively lesser than this one. Okay. So the major axis is x-axis. Now here x square by 16 plus y square by 9 is equal to 1. From here we can just calculate the value of y here. Okay, that I will explain why we are taking y here. So y square by 9 is equal to this x square by 16 we can bring to the right side, that is 1 minus x square by 16. That is, when we take LCM here, 16 minus x square by 16. Then y square is equal to this 9 will go to the numerator here. So 9 by 16 denominator we separated, 9 by 16 into 16 minus x square. Then y, when we calculate root of 9 by 16, that is root 9 is 3, root 16 is 4 into root of 16 minus x square. It is. Now we need to identify the limits. For that what we have to do is, as I said before, this is in the form x square by a square. So here a square is 16 and b square is 9. So from here a we can calculate, a will be plus or minus 4, a will be plus or minus 4, and b will be plus or minus 3. Okay, b will be plus or minus 3, and we need to identify where is a and where is b. So clearly a, as I said, this portion is a and it is under the x value. That means a will be here, this portion is a, from center to this portion, that will be the length of a. So a is plus or minus 4, means this point will be 4 0 and another one will be minus 4 0. Then b means it is along the y axis. Bigger one is major axis value, so that is a we can consider, that is plus or minus 4 here. So this is minus 4 and this is plus 4, and another value is b value is 3. That means from 0 to from O to B, that is 3, and from O to this portion also minus 3. So the coordinates when we write 0, 3 and 0, minus 3. Now area, find the area of the region bounded by the ellipse, means this entire shaded area we have to calculate. And when we consider this portion, it is divided into 4 equal areas. Okay, and if you find out the area of one portion and if you multiply with the 4, we will be getting the total area. So I'm going to find out the area of portion AOB. Okay, And when we apply the limit here, you can check it will be from 0 to 4. Okay, means x value is changing from 0 to 4. And if you are considering a small strip here, so see, for example, if you are considering a small strip here, this will be considering a small strip here, and this we can consider as a dx, small length dx, and another one will be corresponding y value. So the integration formula will be coming as y dx, and the limits we should take from x-axis. So x-axis from this portion, that portion means 0 to 4. Okay, so area of region bounded by the ellipse is equal to 4 into area of OAB of the ellipse. Okay, 4 portions are there. One portion we will calculate and multiply with the 4. That is 4 into integral the x-axis value starting from 0 to 4. Integral 0 to 4 y dx. Okay, y dx. That's why we have calculated here y value. Okay, I told you in the beginning that I will explain later. So why we calculated y here? Because we applied the formula like this. That's why. Then 4 into integral 0 to 4, 3 by 4 into root of 16 minus x square dx, because y dx, y substituted, 3 by 4 root of 16 minus x square dx. That is equal to 3 into integral 0 to 4. This is clearly we know that, because here 4 cancelled, only 3 is there. So 3 we kept outside. And 0 to 4, this is non-format, a square, root of a square minus x square. So root of 4 square minus x square we have written. So root of a square minus x square dx is x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a. This is the formula. Okay, if you don't know the formula, nothing can be done. Only up to this much we can do. So just apply the formula, that is 3 into x by 2, that is written x by 2 into root of a square minus x square, that is here 4 square minus x square, plus a square by 2, a square is here 4 square, so 4 square by 2 into sine inverse x by a, x is x itself, by a is 4. Apply the limit 0 to 4. That means 3 into here, when we apply 4 by 2 into root of 4 square is 16 minus x square, first value is 4, so 4 square is 16, plus then here again 4 square is 16, then 16 by 2 is 8, so it is written here 8 sine inverse x by 4, x is 4, sine inverse 4 by 4 is sine inverse 1. Okay, then very carefully you have to substitute, then minus the lower limit, that means 0 into any quantity, here 0 is there, 0 into any quantity is 0, then plus here 4 square is 16, 16 by 2 is 8 into sine inverse 0 by 4, 0 by 4 is 0. Once again here x replaced with upper limit, that means 4 by 2 into root of 4 square is 16 minus x square, x is 4, 4 square is 16, plus 4 square is 16 by 2 is 8 sine inverse 4, when we substitute 4 by 4 is 1 minus the lower limit, that means first term 0 into the particular quantity 0 will be coming, plus 4 square by 2 we calculated before 8 sine inverse 0 by 4 is 0. Then sine inverse pi by 2 we know sine 90, that is 1. Then sine inverse 1 is pi by 2, so this value we calculated, sine inverse 1 is pi by 2. Next sine inverse 0 we need to calculate, sine 0 is 0, that means sine inverse 0 also 0, so that is 3. Then here 16 minus 6 is root 0, completely gone 0, plus 8 into sine inverse 1, sine inverse 1 is pi by 2, so 8 into pi by 2, then minus 0 plus 8 into sine inverse 0 is 0, so only this value will be coming, that is 8 pi by 2. Then when we multiply inside here, 8 and 2 we can cancel, 4 will be coming, so 3 into 4 pi, that is equal to 12 pi square units. This is the answer. Next we shall discuss the fifth question. Find the area of the region bounded by the ellipse x square by 4 plus y square by 9 is equal to 1. So here first of all we need to identify the type of ellipse here, means major axis we need to identify. So here this is a square and this is b square. Clearly b square is bigger, b square is under y square, means major axis is y axis. So the ellipse is flattened towards the y axis. Okay, means just opposite of the previous question ellipse, that's what. So we have identified already. Equation of the ellipse x square by 4 plus y square by 9 is equal to 1. And as I had discussed before, a square is less than b square, means b square is bigger here. So the major axis is y axis. The ellipse comes this way. You can see the major axis is y axis, means it is flattened towards the y axis. Means this length will be more when we compare with this length. Though this is 2a and this is 2b. Or this is considered as a and this is considered as b. So here b will be bigger than a. Okay. Then here a square is equal to 4. A square 4 means we need the value of a. So a is equal to plus or minus 2 will become. A is equal to plus or minus 2. That is a. And when we calculate b, clearly it is b is equal to plus or minus 3 will be coming. Because a and b we need, because to find out the limits, a and b is necessary. So clearly a is plus or minus 2 means this portion is considered as 2a, means from center to this one is a, from center to this one is minus a. So here this one will be considered as 2 comma 0 and this will be minus 2 comma 0, and b will be 3, means here to here 3. So this will be coming as 0 3 and the bottom will be 0 minus 3. So we identify. Now formula, we need to identify which formula we are going to use. So we will consider a small strip. Okay, and clearly we can take a small strip from here that has small length from the x-axis, that we can take it as dx, and the corresponding y values we can take. Then the area formula is length into breadth, that is y dx, means we will apply x-axis limits. Y dx is the area formula. Then x-axis limit we can take, means from 0 to 2 is taking is enough, because the entire area we have to calculate, but we will calculate only the first quadrant portion, that means AOB, and we will multiply with the 4. That means from 0 to 2 limit is enough, x-axis. So we need here y value. Let's calculate y. From here y we will get y square equal to 9 by 4 minus 4 minus x square will be coming. We know now how to do this one. Then from here y we can calculate y is equal to square root of 9 is 3, square root of 4 is 2, root of 4 minus x square. So then we can calculate the area of the region bounded by the ellipse, that is the total shaded area. 4 into area of OAB. We have discussed before. 4 into area of OAB. So area of OAB we know that is 4 into this 4. Okay, 4 into integral x limit 0 to 2. Okay, because here is x value 0, here x value is 2. So 0 to 2 y dx. Then y value we have calculated 3 by 2 into root of 4 minus x square. So 4 into 3 by 2 into integral 0 to 2 root of, this one we can write it as a square minus x square format, that is 2 square minus x square. We know the formula, that is x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a. If you don't know this formula, you have to stop here, no way to proceed. So learn all the formulas. Okay, that is first. Then here when we cancel 2 and 4, we will be getting as here 2 will be coming the numerator. So 2 into 3 is 6. Then x by 2, that is written x by 2 into root of a square minus x square, that is 2 square minus x square, plus a square by 2, here a square is 2 square. Okay, 2 square by 2 into sine inverse x by a, that means x by a is 2, sine inverse x by 2, apply the limit. Then 6 into, when we apply the upper limit, that is 2 is there, so 2 by 2 into root of 2 square is 4 minus x is 2, 2 square is 4, this limit we applied here, plus 2 square is 4, 4 by 2 is 2, sine inverse 2 applying time 2 by 2, 2 by 2 is 1. Then applying the lower limit applying time minus will be coming, so 0 into any quantity, that is 0. Then here there is a plus, but applying limit time there is a minus sign, common is there, so that minus we have taken inside. So this will be coming as 2 square is 2, 2 by 2 is 2 square is 4, 4 by 2 is 2, 2 into sine inverse 0 by 2, that is 0. Then 6 into, here 2 by 2 into root of 4 minus 4 is 0, so 0 into 2 by 2 is 0, plus 2 sine inverse 1. In the previous question we have calculated sine inverse 1 is pi by 2, here 0 minus sine inverse 0 is 0, so only this portion will be coming 2 into pi by 2. So 2 cancel, here 2 cancel, only 6 pi is coming. Okay, 6 pi square units, that is the area. Next we shall discuss the sixth question. Find the area of the region in the first quadrant enclosed by x-axis, line x is equal to root 3y and the circle x square plus y square equal to 4. This is the question which we are going to do in a different format and a little bit lengthy also. You need to keep the algorithm in mind, how we have to proceed to the answer. So here, find the area of the region in the first quadrant. That particular region is coming under first quadrant, enclosed by x-axis. There is a line and there is a circle. First of all, when we consider this circle, x square plus y square equal to 4 is the equation is given to us, and we know the general form of a circle, that is x minus a the whole square plus y minus b the whole square equal to r square. But here a and b is not there. That means a and b are 0. That means center is 0. So equation of this circle means that from this equation we can just identify the center. Center we can just identify as 0, 0. And then same way radius also we can identify. Radius is equal to r square equal to 4. That means r is equal to 2 units. So from the circle we have identified. Then just roughly we can just draw a diagram by using this one, that we will do it. Then after that what we can do is this x square plus y square 4 we have to take, and then from there we just calculate the value of y. So y square equal to, take this x square to the right side, 4 minus x square will be coming. Y is equal to root of 4 minus x square. This one, it is clearly in the form a square minus x square. So just to keep it and write in the form root of 2 square minus x square. That keep it ready because we need to do integration also. Then we can just roughly draw the diagram. So axis we have drawn x-axis, y-axis, and this is the center 0, 0, and we know the center, that is center of the circle, that is 0, 0. Then that means origin. Then r equal to 2. Radius is 2. Means the circle comes this way and the radius is this length. Okay, from the center to any point on the circumference. I am considering the x-axis portion because we need the area under the first quadrant. So means this portion I am considering, and here the coordinate will be, this length is 2 units. That means the coordinate will be 2, 0 we have considered. The circle is ready. Now one more line is there, x is equal to root 3y. So how we have to draw the line here, which way the line comes, we don't know. For that what we have to do is, we learned previously how to draw lines in the graph sheet. Simply just to take table of values, find some, substitute some values for x and y and get some corresponding y or x values. So x is equal to root 3y we have taken, then corresponding table of values we can make. While making, make sure that easy values you should take. Okay, complicated calculation you should avoid. First I am putting x, y we can put 0. Y putting 0 means x is root 3 into 0, 0 will be coming. Then next I am going to put y is equal to 1. If I put y is equal to 1, x will be root 3. So it is substituted here. So 0, 0, 1 point, and root 3, 1 another point. So we have got 2 set of points. 2 set of points is enough to get a line. First point is 0, 0. That is okay. The next is root 3. Root 3 value we know it is 1.7 almost, approximately 1.7. 1.7 we know here to here length is 2 units. Means 1.7 means somewhere here near to 2 will be coming, 1.7. And 1 unit maybe up to here is 2 units. 1 means somewhere here will be coming. So approximately we can just plot the 2 points. 1 point is here, another point somewhere here will be coming. Okay. So by using that 2 points, simply we can draw a line. Okay, just to keep it ready. This one is 0, 0, and this is something root 3, 1 approximately. Now then we have identified the shapes. One is a circle and another one is a line. And this circle and the line is intersecting at 2 points. Here you can see this is 1 point and this is another point. Of course here when we check it is root 3, 1 and all drawing time, we have got this point. That is the way we are thinking. It's actually not like that. Root 3, 1 is maybe somewhere inside also. We don't know that. But that we have used for drawing this line only. Actually that line and that circle intersection point is, and we still now we didn't find out. So that is our next step. We need to identify the intersection points of the circle and the line. Here one intersection point is there, here also one intersection point is there. Actually we need this one. This one is enough because we are going to find out the area under the first quadrant. Okay, so for finding out that, how to find out the point of intersection, that is very important thing you need to keep in mind. It's quite simple. Take one equation and substitute it in another one. So here x square plus y square equal to 4 equation is there. Here x value is there. This is another equation. Take this one and substitute in this one. So points of intersection calculation, putting y is equal to x by root 3. So you can see here y, when we calculate, root 3 comes this side, x by root 3. In x square plus y square equal to 4. When we put x square plus y square means we are getting x square by 3. Okay, x square by 3 is equal to 4. So y is this one, squaring time x square by 3 will become. When you take LCM, 3x square plus x square equal to common denominator 3 is there, that you multiplied here, 3 into 4, 12. 4x square equal to 12, then x is equal to plus or minus root 3 will become. X square 12 means x square will be 12 by 4x square is 12. So x square is 12 by 4. 12 by 4 is 3. X will be root of 3, plus or minus root of 3. This simple calculation, do it mentally because it takes a lot of time to, if you write all the steps. X is equal to plus or minus root 3 we have got. So x values if you have got, then y value how do we find out? Take that x value and substitute in this first equation. Okay, so actually this one we have taken and substituted here. By using this one only we have calculated the x value. Then that particular x value take and substitute in this equation. That is, for x is equal to root 3, what will happen? Y is, here we calculated it before, y is equal to x by root 3. That means y is equal to 1 by root 3 into root 3. Okay, that is, here you can see x by root 3. X is what? Plus root 3 is substituted. So root 3 cancel. Finally we are getting 1. Next, for x is equal to minus root 3, we have two values here, plus or minus root 3. For minus root 3, what we have to do? Y is equal to 1 by root 3 into minus root 3. Here x replace and put a minus. Even 1 by root 3 not writing also no problem. Just minus root 3 by root 3, that is equal to minus 1 we have got. So the set of points we have got. What are the set of points? For x is equal to root 3, y we have got 1. Okay, root 3 and 1. Another one is for x equal to minus 3, we have got minus 1. So the point of intersection between the line and the circular, root 3 comma 1 and minus 1 comma minus root 3 comma 1. You see this root 3 comma 1 already we have plotted here. See root 3 and 1, it is a point on the line. So this is also a point on the circle. So this is considered as a point of intersection of line and circle, root 3 comma 1. This one you can simply neglect because this comes here. That is not necessary for us. So that point we can write the point of intersection now. Clearly we have got this is the point of intersection. The coordinates are root 3 comma 1. Now we can just complete the diagram, original diagram we can take. So this is the portion, and here this one we can consider it as AOB, the shaded portion area we need to calculate. Means area below the curve, it is in the first quadrant and which is forming along with the x-axis and also with the circle. So this is a portion, and this shaded area we can split it into two portions. Now you see here AOAM. This is a triangle, and clearly this is a triangle. There is no curved portions are there, so directly we can find out the area by using the area of triangle formula. But here there is a small portion which is coming in between this line and this circular portion, this arc. So, or the curve we can say. So this portion area we can calculate by using integration method. When we add these two areas, we will get the entire area. That is what we are going to do. Okay. So this is a little bit of lengthy work, but if you know the process or the algorithm, it is very simple. Here first, once again, we will recall it, these steps. First, what we have done is, we have identified the circle with center and radius and simply plotted. And we have identified the line which way it goes. So the line goes this way, and next process is very important. We need to find out the point of intersection of these two shapes. So line and circle. While for finding out the point of intersection, what we have to do is take one equation and substitute the corresponding variable value from the other equation. Take and put it in the first equation. So here what we have taken is circle we have considered, and substitute this value of y, what we get from the line we substituted here. Then we have got x value, and this x value will take and put it in this line equation. We have got the point of intersection, that is root 3 comma 1 and minus root 3 comma minus 1. So point of intersection we have identified and we have marked, and now we have identified the entire area which we need to calculate, entire region which we need to calculate the area. So that is OAB is the area, OABO is the area. That area we can split into two parts. One is a triangle, another one is a portion which is under this curve. Okay, so triangle area we will calculate directly by using L into B method, and this area we can calculate by using integration. That we will discuss in the next slide. Now we have got the shape like this, and we have got the point of intersection as root 3 comma 1, and we have discussed before how we are finding out the area of this shape. So area of shaded area OAB, first we will calculate. Area required shaded area OAB is equal to area of OAM, that is a triangular portion, plus area of AMB, that is area under the curve. Okay, that is where we are going to do. First, area of OAM we are going to calculate. Area of OAM, as I said before, clearly it is a triangle. Clearly it is a triangle means we know the formula 1 by 2 into B into H. B is OM and H is AM. So OM length we know, this is a root 3. Here it is mentioned, OM is a root 3 and AM is 1 unit. So that is 1 by 2 into root 3 into 1, that is a root 3 by 2 units. Next is shaded area AMB. AMB, this is actually a curve. Okay, so that we use the integration, that is integral x-axis limit we have to take. Here you can see this is a root 3. This M point is a root 3 because we have taken here as root 3. So root 3 to this point, this is our radius. Okay, up to here is the radius, that means 2 units. So root 3 to 2, only this portion MB, root 3 to 2, that is the limit y dx. So integral root 3 to 2, we previously in the first step we have calculated and kept, that is y is root of 2 square minus x square dx. That is equal to x by 2 into root of a square minus x square formula we know, integral a square minus x square, we will substitute. X by 2 into integral, x by 2 into root of a square minus x square plus a square by 2 into sine inverse x by a. Then apply the limit. So here x by 2 into root of a square minus x square, that is root of 2 square minus x square plus a square by 2, a square is 2. Sorry, a square is 2 square. It was 2 square by 2 into sine inverse x by 2. Apply the limit here. Then when we apply the upper limit, 2 is the upper limit, 2 by 2 into root of 2 square, that is 4 minus x is 2. 2 square is again 4, 4 minus 4 plus 2 square by 2 is 2, 4 by 2 is 2, that's why sine inverse 2 by 2, sine inverse 2 by 2 is 1, minus of the lower limit, that means root 3 by 2 into root of 2 square is 4 minus root 3 square is 2, sorry, root 3 square is 3, so 4 minus 3 plus here 2 square by 2 as we have discussed here, that is 2 coming, sine inverse root 3 by 2, lower limit we applied, that is 2 by 2 into 0, it is 0, then 2 into sine inverse 1 is pi by 2 minus, take this minus inside, root 3 by 2 into 4 minus 3 is 1, root 1 is 1, so root 3 by 2 minus 2 into sine inverse root 3 by 2 is pi by 3. Then here some 2 we can cancel here, this 2 and this 2 we can cancel, then that is equal to pi minus, this is pi only, pi minus root 3 by 2 minus, and we multiply here 2 pi by 3. Then here pi minus, when we are taking here, this one we are writing first and this one second, means like terms we are bringing together, pi minus 2 pi by 3 like term, that's why minus root 3 by 2. Then here 3 pi minus 2 pi by 3, LCM taking minus root 3 by 2, that means 3 pi minus 2 pi is pi by 3 minus root 3 by 2 square units. Here 3 pi minus 2 pi, that is pi by 3 minus this portion root 3 by 2 square units. So this is the answer. Move on to the 7th question. The question is, find the area of the smaller part of the circle x square plus y square equal to a square cut off by the line x is equal to a by root 2. Here find the area of the smaller part of the circle. We don't know which one is smaller or bigger because still we did not draw the diagram. Okay, unless you draw it is not possible to identify. So just we will keep it for later. Here x square plus y square equal to a square, equation of the circle is given. Clearly it is just similar to the previous question. This equation of the circle means radius, center we can identify. Center is 0, 0, that is clearly visible there because x square plus y square is there on the left hand side, and the radius we can calculate, radius is equal to right hand side a square, square root of that is a radius, that means e. So radius and the center we have identified, so simply we can draw a circle. So this is a circle with the center 0, 0 and radius a, 0, means O to M distance is a, so a, 0 is this point M. Then next what is given, cut off by the line x is equal to a by root 2. So where is the position of a by root 2? A is a constant and root 2 is also a constant, but we don't know where is a by root 2. So a by root 2 we can just find, roughly we can calculate what is a by root 2. See, I'm taking that 1 by root 2. 1 by root 2, if you consider 1 by root 2, when we rationalize, we will be getting as a root 2, then divided by root 2 when we multiply, we'll be getting like this. So 1 into root 2 is a root 2 by 2 will be coming, root 2 by 2. Root 2 value we know, that is just we can take only one decimal place, 1.4 we can take by 2. 1.4 by 2 is 0.7. Approximately 0.7 is 1 by root 2. That means here we are having a by root 2. A by root 2 means when we put a along with this one, we will be coming as 0.7 a will be coming. Rough work only this one, okay? 0.7 a will be coming. That is x. X is equal to 0.7 a will be coming. Then where is this 0.7 a? That is what first. Here 0 to m distance is a. A means 1 a. So 0.7 a will be just behind of this a. That means somewhere here will be coming. Approximately just close to a. 0.7 is close to 1. So that's what we have taken here. 0.7. Approximately we have taken. Then through that we have drawn a line, that is x is equal to a by root 2. Now there is a common portion. Find the area of the smaller part of the circle cut off by the line x is equal to a by root 2. You see here, smaller part, when this line is cut, when the circle is cut by this line, it is dividing into two portions. This is a larger area and this is a smaller area. Left side is larger and the right side is smaller. So we are asked to find out the smaller part of the circle area. So this portion, shaded portion, we need to find out. Shaded portion, how do we find out? For that, what we have to do is, first we have to find out y. So x square plus y square equal to a square. From here we can calculate y equal to, this x square comes to the right side, a square minus x square. Y, if you want to calculate, take the square root of a square minus x square. So area of the smaller part of the circle means, you see that there is two identical portions are there. We will calculate the upper portion, multiply with 2, then we will get the total area. That is area of ABMC we have to calculate. ABMC, this entire area we have to calculate. How do we calculate? 2 into area of ABM. 2 into area of ABM. Okay. So this is the way we are going to calculate. So this is area under the curve. We need to do integration. That is 2 into, this is the point, starting point, lower limit. That is a by root 2. And this is the upper limit. That is x value is a. So a by root 2 to a y dx. So a by root 2 to a y dx, then y we have calculated, that is root of a square minus x square. Yes, simply substitute and apply the limit and find out the rest of the work. That portion we will do it as homework. Dear students, today we have discussed first 7 questions from exercise 8.1. Go through all the questions and practice it properly. While practicing, if you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.